Hi, my name is Axel Feldman. These past few months I worked at the Mayan lab at Mount Sinai. I'll be presenting the slideshow originally prepared by Ed Chen. I will be primarily going over the basics of the Python programming language, and in the next lesson I will explain one of Python's applications in bioinformatics. Before we can use Python, we have to install it. For the purposes of this class, the easiest way to install is from Install. You will first need to register a free student account and then install their Canopy programming environment. It contains all of the packages that we will be working with, and many, many more. Also included is some cool visualization software and programming tools. However, if you do not care for Canopy, you can easily custom install Python yourself. You will need to start with a simple Python 2.7 base. Either 32-bit or 64-bit will work for the purposes of this course. From there, you will need to install 3 primary scientific packages on top of the Python base. These are NumPy, SciPy, and Matplotlib. All 3 of these are readily available from the links on the slide made possible by Christoph Kolke at UC Irvine. It's really amazing that he made packages with installers for every single one of these modules. It's very helpful and very easy, much easier than installing them manually. Now, what is Python? It's a relatively simple programming language that is easy to learn, easy to use, and very readable. It runs slower than many other programming languages, but it's definitely concise. All of these are positive attributes, which make it a prime candidate for the work which we will be doing here. Python's simple syntax will also make it easier for you to follow the code samples posted throughout these lectures. Python, like most programming languages, has variables. However, unlike many other languages, Python variables do not need to be specifically defined when created. This does not, of course, mean that they are not separated into different types. The type is simply defined by the initial values assigned to a given variable. If you put in a number, it'll store it as either a float or an integer, but we'll get into that later. If you put in text, it'll store it as a string, and if you put in a list, it'll store it, well, as a list. But again, we'll get into the data types later. The type is just defined by the initial values assigned to the variable. Variable types include booleans, integers, floating point numbers, strings, lists, tuples, dictionaries, sets, objects, and functions. You can define more types yourself, but that is far more advanced. Displayed here are a number of simple mathematical operations with integers and floating point numbers. In the most basic sense, a float stores any rational number, and an integer stores, well, an integer. So here you can see that we are defining an integer simply with a 9, and we define a float with a number with a decimal point afterwards, so 10.0 in this case. We can add integers, and integer divides will yield an integer. On the other hand, if we divide a float by either an integer or by another float, we'll get, again, a float. So 3.33 is what we get when we divide 10 by 3, whereas if we were to do it with integers, we'd only get 3. Strings are a way to store any alphanumerical characters or any form of text. Starting here with a traditional hello world string, we can see that we can index strings. Here, the test string brackets 0 indicates that we are taking the first character of that string, because the numbering of the characters starts at 0. So test string of 0 is h. Strings also have a given length, which can be found using the len function. So here the length of hello world we can see is 12. This outputs as an integer. Strings then afterwards can be played around with and processed, as you see in the second example. Here we define string of 2 as something which is pretty obviously to the human eye a list of 1, 2, and 3. However, to a computer, it won't be able to read that as we can, so we need to process it a bit. So first we use the rstrip command to remove the new line character at the end and make it just 1, 2, and 3. Then afterwards, we can use string.split, and we split given a comma, to split the string at every point where there is a comma. This will then output a list of 1, 2, and 3. Now that moves us on pretty nicely to lists. Lists are any way of storing, well, a list of information. So they're separated by brackets, they're defined by brackets, and they also can be indexed. And just like strings, you can also do ranges of indices. For instance, you can see that test list 0 through 2 will yield 2, 1, so the first 2 elements of the list. And test list of 2, will give everything after the second character in a list, so 3 and 4. Lists can also be sorted, reversed, and we can add to them using the .append command. They can also be extended by adding in another list. Please just note that if we were to append this other list, then the list would be appended as a list to our current list. So we'd have 2, 1, 3, 4, and then a list of -1, 2, 3. Whereas if we use .extend, the list will just be extended with these 3 elements. We can also test membership of a list using the in command. So here we can type 6 not in list, and that will say true, because 6 is in fact not in the list. However, we could also do 4 in list, and that would give us a true, because 4 is in the list. So moving on to the next couple data types. Tuples are similar to lists, but they cannot be added or removed to following their creation. This is called being immutable. They're used for similar kind of purposes. However, again, they can't be edited as we go along by our program. In this case, we can also show that they can have a maximum and a minimum value, like a list, and this is done just based on the elements in the tuple. Then afterwards, we have dictionaries. Dictionaries work very similarly to a way an English language dictionary would work, for instance. We have a series of keys, and then we have a series of values. In an English language dictionary, the keys would be the words, and the values would be the definitions. However, in a Python dictionary, we don't necessarily have to have words and definitions for it to work. Here we define burger to be $5.50, so the sample cost of a burger, and shake to be 3. However, if we were to do test dict of burger, we'd then return the value which we stored under burger, which would be $5.50. So you can find values in a dictionary simply based on their key. Then afterwards, we can also find a list of all the keys in a dictionary using dictionary.keys, and the list of all the items or values in a dictionary using dictionary.items. This can be sometimes useful when you just want to see what you have in a dictionary and the length of a dictionary, which cannot be found by doing a simple len command. Another data type is the set. Sets work very similarly to mathematical sets. You can get their unions, you can get the intersection, you can get the complements, you can get the union of the complements and the intersection of the complements, and everything else which we could do with a simple mathematical set. Another interesting feature of sets is that we add to them using the .add command, which, unlike in list where we use the .append command. And another sort of useful feature is that if you ever want to remove duplicates from a list, you can define it as a set and then define it as a list again, and that will have removed all the duplicates. Finally, there are many different types of objects which we can work with later on, and these must be defined yourself. So this is a bit more complicated, but you can define methods for them, and you can define many other things for your own objects. As is written on the slide, Python uses colons and indentations to denote blocks of code, such as the if sample. Here we just check if a number is greater than 0, then we print that it's greater than 0 if it is. We can also do an elif saying, is the number less than 0? And finally, if it's neither greater nor less than 0, we can tell that it is 0. And this is defined by indentations and colons, as you can see in the code sample. There are many different types of loops in Python. Well, not many, but 2 basic types. There are while loops and there are for loops. So while loops give you a lot more control as to when to enter and exit, but for loops are very simple to code. Below are just 2 examples of for loops. You can see here that we give ourselves the list of values, and then we can iterate through, so for value and values, and we can add to a total. Similarly, we can also iterate through the range of numbers of the length of the values. So here that would actually be the same because we have values 1, 2, 3, 4, 5, and the range of the length would also be 1, 2, 3, 4, and 5, but again, that's just this particular example. Functions are an easy way to break up your code. Each function does a specific task, most of the time taking inputs and generating an output of some kind. Within a function, you can work with any one of your inputs, known as arguments. Python is unique in that it can provide multiple results by putting functions together in a tuple. These are then individually accessible via their indices within that given tuple. So you define functions using the def command as seen here, and you take the argument here values, and then you can work with them, and you end with a return command as seen at the bottom. And this will usually work very well, and you can call it later and work with that function just as a block of code, but only put it in as one line later on. So Python can truly go much farther than what was covered in this basic introduction. The language gives you the option of coding almost anything you want. Some of the more advanced concepts are the while loops mentioned earlier, more data structures, list comprehensions that allow you to programmatically alter a list in one line of code, lambda, regular expression commands that allow you to find substrings within strings, classes, and exceptions. From here you can truly go wherever you want.